Hello. So in this video, I'm going to teach you how to make a QR code manually. That means without any QR code generators and all. I'm making this video because I think there are not many videos or information out there in websites also, which tell you about these things, how to make QR code without any generator. If you see in YouTube, you search how to make a QR code without any generators, you see there are not many useful videos, and that's why I am making this video. You might ask, why should we learn about these, or why can't you just use a QR code generator? But I will ask you, why not? Yeah, why not? So let's just start. Yes, the first thing you need to do is to select a message that you want to input in the QR code, in your QR code. And if you're doing this for the first time, I think you should start with a version on QR code, and a version on QR code can hold 16 letters maximum, and you should work with 16 letters. Even if your message has 10 letters, you should make it 16 letters by adding some extra letters. So it can hold 16 letters or bytes. We have to turn each letter or character into 1 byte of information. 1 byte means a data string which has 8 bits, 0, 1, 0, 1, 0, 1, 0, 1. Each of them is called a bit. Together, this thing is called a byte. So you need 16 bytes of info. That means you need 16 characters. So let's take any message. The message I did was Q space R space made by Asif. There are 16 letters. Now the thing you need to do is to select a mode. And by mode, I mean there are 4 modes which you can use to input your data into the QR code. There is a numeric mode in which you can only use or only input numbers in your QR code. There is an alphanumeric mode, there is a binary mode, and there is a Japanese, which is kanji mode. So you can use this alphanumeric or binary, but I will suggest you to use binary because the maths for alphanumeric is a little complicated, but it is easy. Binary is easy. Yes. So we have our message and we have selected our mode. Next thing we need to do is to convert our message into binary, because we are working with binary mode, right? So we need to convert into binary. So how do we convert a alphabet? Suppose we have an alphabet Q into a binary byte. Okay, so there is a process, or there is a code actually. Let's show you. Yes, you see there is a code, that is ASCII decimal code. ASCII stands for American Standard Code for Information Interchange. They have assigned on decimal number actually, to each of the letters and the symbols, space, stars, hashtag, each of them. There are total 256 ASCII decimal codes they have assigned each to a specific letter, like each of the upper cases, lower cases, each of them. So you have to first turn your whole message, you see, each of the letters into ASCII decimal. Okay. And after you have done that, now you have to convert your ASCII decimals into binary. And to convert any decimal number into binary, you can use converters, decimal to binary, or you can do it yourself. It's not really that hard. Let's see, we have 80 on. What you do, you just divide 80 on with 2, and we cannot actually divide 81 with 2, but we can divide 80 by 2, and the result is 40. So we have 1 extra, and you just keep repeating this process. 40 is divisible by 2, and the result is 20, and we didn't do anything or subtract anything, so this is 0, then this is 10, this is 0, then 5, this is 0. 5 is not divisible by 2, so you take 4, you divide 4 by 2, and you get 2, but you have to subtract on from 5, and then 2 is divisible on, and then you go this way. So the decimal binary string that you have for 81 is 0 1 0 0 0 1 0 0 0 1. But if you notice, there are only 7 bits in this string. So how do we make it in a 8-bit string or a byte? To do that, you just add on 0 in front of it. If it was made of 6 bits, then you had to add 2 zeros, and if it was made of 5 bits, then you had to add 3 zeros, like that. You just have to make it a 8-bit string, and you repeat this process for each letter or character. Then you should have this total binary string of 16 bytes. 16 bytes. Okay, so we have done this. Now you have to make an error correction. Oh, so there are some things you should know before going to error correction. Like, yes, like that. Why did we take 16 bytes for version 1 QR code? And those informations you can get from an website which is called honky.com. It's really a good website for the informations about QR code. And here you see, for a version on QR code, if you apply level L of data correction, which I am going to talk about later, you need total 19 bytes of data coders, and among the 19 bytes, there are some bytes reserved, approx 3 bytes reserved from some information, and the remaining 16 bytes you can use as your data. And you can see you need 7 bytes of error correction coders. Okay, so let's get back to our notes. And yes, so now we have that we have 16 bytes of original data. We need to convert it in a in an error correction. Convert it in a 7-byte error correction. But you cannot just error correct for your original data. You have to add the mode indicator, the length indicator, the padding bytes, the n bytes along with it to make it a 19-byte info or data bit string, binary string. You need to make a 19-byte of binary string, then you convert it in a 7-byte of error correction. So how do I make a 16-byte of original data into a complete data of 19 bytes? Let's see. How do we do this? First, you need to do is that you place your 16-byte of original data. Sorry, it should have been there. 16 bytes of original data. The first four bits of the total data should indicate the mode. And as I told you that we are using binary, and the code for binary mode indicator is 0100. So you place 0100 and you call this mode indicator. Then you place a length indicator, and the length indicator tells you about how much of original data that you have. Original data. So we have 16 bytes of original data. So we need to convert 16 into a binary. So let's convert 16 into binary. 80402010, and they are 100000. Okay, sorry, 4 zeros. So you would need 3 zeros in front. That's a byte. Okay, so we have the mode indicator, the length indicator, the original data. Then you place 8 zeros, just 8 zeros, which you call padding. Then you place 4 zeros. This indicates the end of the message. After putting any amount of original data, you need on padding byte and on end message byte. Even if you have had 15 bytes of original data, you would need 2 padding bytes, and then you have to place the end message, that is 4 zeros. And now you use error correction, or you make an error correction for this total 19 byte, 16 byte. This 8 zeros makes 17 bytes. This length indicator 18 bytes, and this 448 bytes, that means 19 bytes. Okay, 19 bytes into an error correction. So how do we do this error correction again? To do this, we have an equation which was developed by Reed and Solomon, and we name this process read-solo data encryption. And sadly, we cannot do this on our own, because the maths for this encryption is too long. You need to learn polynomial to do this on your own. Rather, what we do, we can use an Python code to do this. Let's see Python. If you have Android device, you can download Pyroid. First, you need to download here PIP, I guess, and you need to download the Read Solo library. It says it is installed successfully. Then you have to run on code. The code should be, I have already that code in my files. Okay, downloads. The code, quick share. Here it is. Read Solo. Read Solo. Okay. Now you can. I will copy paste this code in the comment section. You can access the code from there, and you see this code was made by ChatGPT, but there are some changes which I made to make it easier. First, what you do is you put your 19 bytes of data in here. You can see, copy paste here, and I made this so that the result will be in binary. So you run this, and here it is, your 7 bytes of data encryption in read solo. So what you do is you copy, and you just use this data, use this dot error correction here, 7 byte read solo error correction. Okay, this is your complete data. That means this your complete data is 19 bytes of total data plus 7 bytes your error correction, 26 bytes of complete data with everything you need. Okay, so we have learned how to make the error correction of the 19 bytes. Yes, now that we have the complete data, we have to put this manually within our QR code. So to do this, you need an application or any or you can even do this on your notebooks and make a grid of 21 by 21 yourself with pens and colors. But using an app, any painting app, will help to make the process really easy. So you need on 21 into 21 grid, and I will suggest you to color the grid in any color other than black. So that when you are filling each block with black, suppose this, you can just make them white again by filling white. But if you had used a black grid, you would not have out. Let me show you. There is the black grid. You fill this, and you think no, it should have been white. Do this, and there is the result. So I would suggest you to use any color except black, and here we go. So there are some functional areas in a QR code which is same for any QR code, literally any QR code, and you have to place those first. First you need to make 7 by 7 squares on the 3 corners. Almost done. You see, I made a mistake there, and I can just fill it with white color. Okay, so you make these patterns on the 3 corners, leaving the left bottom corner, and these patterns are called finder patterns, and you can see these patterns in any QR code, any version of QR code. There are so many versions of QR code now. You can see these patterns in each of them. So these are called finding patterns. Now you have to leave these area. These are called the separators. Yeah, so the separators should be always white. There is in any QR code you see these pixels or modules, how do you wanna call them, these are always white. So you have to leave these places white, and there is on another these are called separators. Then you have to leave another strips or patterns, these. Okay, different, let's use a different color. Yes, these strips or these patterns are called timing patterns, and these are always in an alternate manner. Always start from black and white, black and white, and black and white, and it is similar for each and every version of QR code that is out there. So how do you do? You fill them in an alternate manner. That means white, black, white, black, white. Yes, you do this for this. White, black, white, black. And there it is. You cannot fill any data on these finding patterns, or within these separators, or in these timing patterns. Even you have to leave these places also. Okay, sorry. Oh, I made a mistake. The alternate pattern starts with black. It starts with black. Black and white, black and white, black and white. Yes. Okay. And the blue areas are reserved for the format information. You have to leave these places also. This. Sorry. Yes. This. You have to leave these areas for your format information. When a QR code scanner is scanning any QR code, these areas tell that scanner that this is a version on QR code. This is a specific masking pattern and the level of correction that has been used and all that. And very interesting thing that this module or pixel is always black, and there is actually no significance to that. The inventor of QR code, when interviewed, once said that uh, after designing the whole QR code, this specific module was left, and he had to choose anything between white and black, and he just chose black. So this pixel is always black. Okay. Now the remaining white portion, you can start filling your total 26 bytes. Total 26 bytes you can start filling here. And so how is the process of filling the QR code? You start from here, and you go like this. You just continue this. You go there, and now you have reached the top. You just continue, and you just continue to come down. You see, you just continue by doing this, going upward. It's like a snake. You're filling 2 modules on, and then you are going up, and when you're reaching the top, you're filling 2 modules, and then you're going down, and you keep repeating this process for the whole QR code. You do this for the whole QR code, and then you place the blue areas with specific format information, which I'm going to tell you about, and it should be working. The QR code should be working fine. Let me just show you the starting bits of the data inputting. Oh, I missed a step, which is called the data masking. Okay. Let's just start filling it with our information or our data. Okay, so the first 4, I told you, the first 4 bits are reserved for the mode indicator, and as we are using binary, so this will be 0, 0, 1. Black is for 1 and white is for 0, 0, 1, 0, 0. Then our length indicator was 16, and it was I suppose 0, 0, 0, 1 and 4 zeros. So you go like 0, 0, 0, 1, 0, 0, 0, 0, and then you fill your Q and R and your whole message here. Then your 8 padding zeros, then 4 end message zeros, then your in data encryption, your whole data sheet you filled here. And then after filling up your whole data, the QR code should look like this. Something like this. Let's take this. Okay. After filling up your whole data, I told you that these places are for format information. Okay. It should look like this. And now what you have to do, after data inputting, you have to mask we have done the data inputting, we have learned about the functional area. Okay, now we have to do the masking. So masking is actually the process of flipping the modules at a certain point. And the masking, there are actually 8 masking patterns. You can use any of them. The easiest are masking pattern 1 and masking pattern 2. And to find the information, I will show you the masking patterns are here. If you are using masking pattern 0, it is a little hard that you have to count each module and its row number and column number, and if it is divisible by 2, you flip the module. But the mask number 1, it is easier. Okay, how do you do that? That is if the row number is divisible by 2, you flip every module of that row. And the masking pattern 2 suggests that you flip the modules of every column which is divisible by 3. So let me show you. We number our rows starting from 0, 1, 2, 3, 4, and so on. So 0 is actually divisible by 2. So you have to flip this row, then 2, this, then 4, this, then this, and so on. So how do we flip the rows? How do you mean by flipping the modules or the pixels? First thing you have to learn that you never flip the modules of the functional area. Functional area being the finding patterns, the separators, the format information strips, or the absolute black module. You do not touch these, but you flip the rest of the rows, like the number 0, you are flipping these 4. See, okay, you are going to flip this flow, so white becomes black and blacks become white. And to do this, you can actually first color the blacks with a defined color, then you fill the white with black, and then you change the color back to white. So this is how you flip the modules or the pixel. Let me show you again. The row number 2 should be flipped, so you turn the black into another color, then you fill up the white with black, then you turn it back to white. So this is how you flip each of the rows which is divisible by 2, which is divisible by 2. Okay, now after doing all of this, now the final moment is final process is for putting the format information. So what is the format information? The format information tells the QR code scanner about the level of data correction and the masking pattern. And here we use the masking pattern on, but which was the level of data collection? The level of data collection we actually used was, let me show you. Where is the Python code? Yes, the level of data correction, if you can see, yes, we're turning the whole 19 bytes of data correction in a 7 byte of data correction, and this 7 bytes of and turning the whole whole sequence in 7 bytes of data correction means you are using level L. When I was making this code, I specified that I want to use the level L, low level of data correction. So now you have the level of data correction and you have the masking pattern. So you have to turn these two in a format info line. So how do you turn them in a format information strip? That you can do with this website, this table. Okay, this no yes, this the level of our error correction level is L, low level, and the masking pattern is on. Okay, so we are using this is the format information. As you can see, the format information strings. Okay, so we have to put this into our here into the blue modules. So you put them on 0 0 on 0 0 on, and so on. And after putting the so how I forgot to tell you the sequence of putting this format information. So let me tell you about the sequence. Okay, there are total 15 bits in a data correct format information string. So you have to place the 16 bits. You start from 16 bits. You start from here and you place your first 1 2 3 4 5 6 bits. Then you place here 3 bits and you place your rest of the 9. That means you should have 6 bits, 6 6 12 and 3 15 has so we have placed our 15 bits of format information. So how do we place the down here and here? We place this again here on the left upper corner. We have already put the 15 bit format string, but we have to put again here starting from here going upwards. You place 7 bits and the remaining 8 bits you put here, 8 bits. So you put this whole string two times, and after putting all of this we have done the format information. Your code should be working just fine. Let me show you one example. Yeah, so this was my final code which I made, and this should work just as fine with any QR code scanners, because these QR codes or the QR codes which are used nowadays can scan anything from version 1 to version 40 or version or any higher version. So you should be able to scan your QR with any QR code scanner. Let me just show you. Here it is. You see, there is the text. So that's all. I hope this video helps. If you are trying to make an QR code all by yourself, yes. So actually, I am a medical student, and I actually don't know anything or much about our Python or your codes and all that. But the QR code, it made me wonder how the QR codes work, and it made me interested to learning about them and how they work, their mathematics, their anatomy, and I tried to do I tried to build the QR code from all by myself. Well, the read solo data encryption is done by Python, because I don't know the math of polynomials and all. The math is really difficult, but yes, this is it, and I hope this helps. If only I don't know if there is anyone crazy enough to try to make the whole code. But yeah, and yes, if you are making the code from this video, you should definitely look out the thonky.com. It helped me really. uh, it really helped me, because you have all this information about the small things about the data encoding, the error correction, the final structure modules, and all. So you should always check this website, and I will link the Python code in the comment section. That's it. Uh, you should try to make on yourself. Yes. Bye.